This is my presentation for Lab 1. So the introduction of the lab is, it finds the motion of a moving object without a change in direction. It used tracker to figure out the object's position at an exact time, and it used code to figure out the predicted position. The coding language uses Python using GlowScript. This is the object. It is a plastic cylinder rolled against a ruler under constant motion with no change in direction. Now, the purpose of the lab is to compare the observed and predicted motion of a moving object in a constant speed. The fundamental physics principles and models used are the velocity update formula, the velocity average formula, and the position update formula, and the combination of Newton's second law of motion and gravity on Earth. Velocity update formula is velocity final equals velocity initial plus F net divided by m times delta t. And the velocity average formula adds the velocity initial and velocity final dividing it by 2. The position update formula is the initial position plus average velocity times delta t. The Newton's second law of motion indicates the final position equals the initial position plus vi times delta t plus 1/2 the times f net divided by m times delta t to the second power. And the main physics ideas used are motion is the indication of a change in position, and the position indicates where a vector is on a coordinate plane, and velocity indicates the speed and direction of the motion, and its change means an interaction has occurred. And the constant force is a push and pull that is even on both sides. And the idea of Newton's second law of motion of mass and acceleration is also playing an effect. Now, the predicted motion is showed and the observed motion is showed by this graph. The red line shows the predicted position and the blue line shows the observed position. Here we can see that the predicted motion is much flatter, than the observed position, which is more vertical than it is horizontal. So as we can see, there is a great difference between both. And the observed position is shown by this graph, which is a straight, even line. The similarities and differences between the data and model: the position graph is steeper for the predicted position than the observed position, and the velocity represented in the predicted position graph is less than the observed position. The system and surroundings. The system and surroundings are at equal force. The system is the plastic cylinder, and the surroundings are the air in the table the cylinder is rolling against, meaning that the F net is 0 because the surroundings of the system have the same force. And the initial conditions of the experiment are: the motion is one-dimensional, meaning only the x-coordinate is being assessed in this scenario, and only accessing the x-coordinate of the position and velocity when referencing the code or the formulas used for the problem. Now, the net force, and just because the net force is equal to 0 does not mean the net force does not exist. We can predict the amount of pushes and pulls by equaling the force exerted by the system and surrounding. The amount of pushes and pulls are exact, so if we know the force of the system, we can find the force of the surrounding. Now, the experiment itself found the observed and predicted position of a plastic cylinder. It first found the observed position by uploading the motion to Tracker. Tracker interpreted the position and velocity of the object, and then using Python, I found the predicted position. Here is the code. The code indicates the object itself being coded, and then the system properties initial positions showing the initial position vector of the object and the initial velocity. Both these values were given to me by the Tracker app. And the delta t 0.03 was also given by Tracker. And over here, as we can see the ball's velocity and the ball's position, which right here is the position update formula. Now, what if the axes were switched from positive x to negative x, there will be no change in magnitude, the velocity will be negative, and the graph will be reflected across the time axis. Now, the possible sources of error are the lag in the video, unaccounted friction on the surface, and rounding errors. Thank you.